Chapter 3, Exercise 16. Hints. For Part A, show that xn greater than square root alpha for all positive integers n, and use this to show that xn decreases. For Part B, use induction and Part A. For Part C, note that if alpha equals 3 and x1 equals 2, then beta less than 4 and epsilon 1 over beta less than 1/10. Solution. A. Firstly, we prove that xn greater than square root alpha for all n equals 1, 2, 3, and so on. If n equals 1, then x1 greater than square root alpha by assumption. If xn greater than square root alpha, then we have this. By induction, xn greater than square root alpha for all n equals 1, 2, and so on. Secondly, we prove that the sequence xn decreases. From the inequality xn greater than square root alpha, we have this. By Theorem 314, there exists a limit x equals limit n to infinity xn greater than or equal to square root alpha. From Theorem 3.3, we have this. It follows that x squared equals alpha. Since x greater than or equal to square root alpha, we deduce that x equals square root alpha. B. We compute this. And this. From inequality xn greater than square root alpha, we deduce the following, where beta equals 2 square root alpha. We prove that this by induction on n. If n equals 1, then the following, and the needed statement holds. If this, then that. So we have this for all n equals 1, 2, 3, and so on. C. Let alpha equals 3 and x1 equals 2. Clearly, x1 equals 2 equals square root 4 greater than 3 equals square root alpha. Further, this, indeed, that. And this, also note that the following. Estimates from Part B imply this, in particular, this and that. Comments. The approach to approximate square root alpha given in this exercise is a method of finding a solution to the equation f of x equals x, where we have this. Such solutions are called fixed points of f. Note that the only positive fixed point of this is square root alpha. See exercises 522, 524. An estimate of the error of approximation epsilon n is reasonable when we have this, so the initial guess x1 is important. Thanks for watching.